Hi everyone, this is Dr. Battula Babu. Now, this is our first class of energy conversion engineering. So, as you all know, in place of face to face lectures, because of COVID-19, we are changing to online video lectures. So, in online video lecture series, this is our first class. So in this lecture, we will discuss about our first class, that is outlines of our lecture, and also we will discuss few things of our lecture. Uh, Thank you for choosing this course, and okay, let's start our lecture. Yeah, this is our title, Energy Conversion Engineering. Uh, as I mentioned, my name is Dr. Battula Babu and School of Mechanical Engineering, Yangnam University, and this is my mail ID. So if you have any doubts or if you want to inform something to me, you can contact through this email. I will respond as soon as possible I receive your mails. This is our syllabus. Uh, in our course, so these are the topics. Actually, in our lecture we have 15 classes, and these are the 15 classes outlines. That means topics in every week. I think you already aware of this, because I posted in this in our university system, and this is our syllabus. As I mentioned, we have 15 classes. So I want to read all the topics which we are going to cover every week. And firstly, we will that means today we will discuss, or we will read the outlines of the course, and followed by, and the second one is energy resources and environment, and the third one is energy conversion and storage, introduction to supercapacitors, properties of supercapacitors, preparation and electrode materials for supercapacitors, preparation of electrode materials for supercapacitor, because for supercapacitor point of view, we need to know more details about preparation of electrode materials. Therefore, we are taking two classes for this topic, and followed by midterm exam and testing of supercapacitors. This topic also takes two classes, and then hurdles in the performance of supercapacitors, emerging 2D materials, 2D nanomaterials for supercapacitor applications, carbon based nanomaterials for supercapacitor applications, oxide based nanomaterials for supercapacitor applications, and final exam. So briefly, in this course we will know about nanomaterials, preparation of nanomaterials, and particularly preparation of nanomaterials for supercapacitors, and how to test or how to perform the supercapacitors, and what is the drawbacks of supercapacitors, and what are the promising nanomaterials for the enhancement of supercapacitor performance. We will discuss about different kinds of morphologies, carbon based material, oxide based materials. So there are different kinds of materials based on morphology. So we will discuss about in details of the preparation, testing, and performance of supercapacitors. So actually, in any present scenario, in any field, whether it may be supercapacitors or battery or any energy related field, the we all are aware of nanoscience and nanotechnology, because this field, nanoscience and nanotechnology, changes the technology of whole world. And similarly, in our topic, that is supercapacitors, supercapacitors in supercapacitor field, nanoscience and nanotechnology plays a vital role and a very important role. That's why before going to discuss about supercapacitors, it is essential and necessary to know what is nanoscience and what is nanotechnology and how it plays a major role in any kind of technology and also supercapacitors. So before discuss about nanoscience and nanotechnology, I want to tell you we need to discuss about what are the general terms used in nanoscience and nanotechnology, and what is the history, background, classification of nanomaterials. Classification of nanomaterial means we all know that, so there are different kinds of nanomaterials. That means based on dimensionality, based on morphology, and based on different kinds of properties. So there are certain classifications of nanomaterials. Similarly, properties of nanomaterials, applications of nanomaterials. We all know that nanomaterials have different properties and many applications in many fields. Advantages of our coursework. So if you after taking this course and this curriculum, you will able to benefit regarding these points. One of the biggest benefits of coursework helps to improve understanding in material science. Particularly, supercapacitors is a topic or it's a branch of science, so which include mostly materials science. And for especially it will be useful in mechanical engineering, because we need to prepare nanomaterials to make supercapacitor, which will eventually useful to make supercapacitors. So you will be benefited through this coursework. You will learn synthesis of nanomaterials in various morphology, because preparation of nanomaterial is very important uh, to get the good performance of supercapacitor. So first thing, we need to know how to prepare a nanomaterial, and analysis of synthesized material with various sophisticated analysis tools. Because after preparing a nanomaterial, you need to know the morphology, and you need to know the properties, you need to know how to make a supercapacitor, and you need to know how to test a supercapacitor and its performance. So we need to use sophisticated analysis tools, and we will learn and you will learn how to how to use different kinds of testings to estimate the performance of a supercapacitor, and you will learn in-depth supercapacitor applications. So these are the advantages of our coursework. Yeah, coming to what are the general terms used in nanoscience and nanotechnology. So most of the people know, and I think I believe you aware of this basic terms. Anyway, I want to discuss the basic things about nanotechnology, because we need to go further the in-depth of nanomaterials. So we all know the term nano comes from a Greek prefix meaning dwarf. Nano means it is very small. So you can estimate, you can know the nanometer means 10 to the power minus 9 meters. So that much very small. So nano word comes from a Greek word. So that is meaning dwarf. A nanometer is 1 billionth of a meter. So you can imagine how small it is. A nanometer is 1 billionth of a meter. So it is very small. Nanomaterials are commonly defined as materials having at least one of the dimensions ranging from 1 to 100 nanometers. So how a material can be treated as a nanomaterial means, so you all know we have one dimensional material, two dimensional, three dimensional. So if you take a cube, it is a three dimensional material. If you take a rod or wire, it is a one dimensional material. So of course, if the three dimensions, lengthwise, widthwise, like that, so in any one dimension, if it is below 100 nanometer, then it can be treated as a nanomaterial. For example, if a cube has length, width, height, both all the three dimensions is more than 100 nanometers, then we could not treat as a nanomaterial. So one dimension, it may be length or width or height, should be less than 100 nanometers. So therefore, nanomaterials are simply one of the dimensions should be less than 100 nanometers. Then nanoscience. So nanoscience means it is a study of properties and its effect when material attains nano scale. So the main important thing of nanoscience, or the beauty of nanoscience, is a material exhibits differently when it comes from bulk material to nano material. For example, if a cube having greater than 100 nanometers in all directions, it shows some properties, but if the same material comes below 100 nanometers, it shows different properties, entirely different properties. That means, so one, if for example, if a bulk material shows opaque nature, with the same material below below 100 nanometers, it may be transparent. For example, if a bulk material shows uh, non-magnetic nature, the same material below 100 nanometers, that means in nano scale, it shows very good magnetic material. So that means, so the nanoscale or the nanoscience is the branch of science which deals or which studies the properties and its effect when it comes under nanoscale. Then coming to nanotechnology, art and science to designing functional materials, devices and systems at nanoscale by controlled manipulation of size and shape of materials having superior properties than bulk. As I mentioned earlier, nanoscience or nanotechnology means we need to study the properties, or we need to make the devices which shows entirely differently when it comes from bulk stage. And then we need to know how small is nano. Actually, we could not able to see with our physical eyes, and it is little tough to guess or to know how much is nano scale. But you can imagine, or you can compare with from bulk to nano material. So yeah, let's see this. This is from microorganisms which we can able to estimate from microscopes. Yeah, I think see this from 1 millimeter to 0.1 nanometer. So if you see some this bacteria or viruses which comes are from our human hair, see this, our human hair, it is in terms of 10 micrometers, 10 micrometers. Our blood cell is about 100 nanometers. DNA is about 10 nanometer. And so this is the buckyball carbon, so it is comes to 0.1 nanometers. So that means, so our physical vision is little bulk, it's a bulk material. So when you come down to the size, so then you can able to see the how much small is a nanomaterial. So simply one could not able to see physically, as the size of the object is going down, down, down. So a nanometer is very, very small, which sometimes you cannot able to see with usually observable microscopes. You need high resolution microscopes like SEM, scanning electron microscope, TEM, transmission electron microscope. You need highly sophisticated equipment in order to see or observe the things which happen at nano scale. So finally, a nano materials are existed in our nature, but we could not able to see, but we can able to see or observe by highly sophisticated equipment. And nanoscience and nanotechnology is, it's not related to only one part of science, but it is a multidisciplinary science. It is not only related to physics, it is not only related to chemistry, it is not only related to any branch of science, but it can be, it is a multidisciplinary subject. So that's why this nanoscience and nanotechnology is very important to know how it is useful, how it plays a role in our coursework, that is supercapacitor. So to understand the supercapacitors or to know about supercapacitors, it is essential to know what is the science behind the performance of a supercapacitor. That science nowadays is simply a nanoscience. So through nanoscience only one can able to achieve high performance supercapacitors. Yeah, so this nanoscience and nanotechnology is related to chemistry, it is also related to physics, it also related to engineering, it is related to biology, it is related to medicine, it is related to materials, science and biotechnology, information technology also. So that's why nanoscience and nanotechnology is a multidisciplinary subject which everyone, that means which every science student, every engineering student must know about the nanoscience and nanotechnology, because it is a multidisciplinary science which finds applications in all the branches of science like chemistry, physics, material science, physical science, biotechnology, nanotechnology, including medicine and information technology. So this is the beauty of nanoscience and nanotechnology, which is essential for everyone. Yeah, coming, why nanomaterials are important, or why, what is the major effect of nanoscale? So see here, nanomaterials have exhibits superior properties than bulk substances. Some are known, but there may be some more to be discovered. Actually, when a material comes from bulk material to nanoscale, you can find a drastic change in its properties. Almost every property has been changed while it comes from bulk to nano. See the first point, the electronic and optical properties. So when a material, for example, whether it may be a zinc oxide, tin oxide, like that, every materials, most of the materials, when it comes to nanoscale from bulk, its electronic properties on optical properties may be changed. For example, if a zinc oxide or some other material, if it is transparent to light when it is in bulk stage, but when it comes to nanoscale, it is a magnetic material, it is a transparent material. So likewise, mechanical properties will change, thermal properties will change, chemical properties will also change. For example, if a bulk material have less strength, the same material in nanoscale have more strength. If a bulk material have a rigid nature, the same material at nanoscale will have soft nature. So that means, so there are so many changes in its properties, in all the properties, electronic properties, optical properties, mechanical properties, thermal properties, chemical properties, like that. So what is the reason behind the changes of its properties? What happens when it comes from bulk stage to nanoscale? So that is important. We need to know what is the reason behind the nano science, why all the properties are changing for the same material. Because when a material comes to nanoscale, what happened is its surface area is increasing. That means a bulk material have low surface area, but a nanomaterial has high surface area. And also large fraction of surface atoms. Large fraction of surface atoms means in bulk material most of the atoms are placing inside the material. But when it comes to nanomaterial, almost most of the atoms comes to the surface to participate in a reaction or something. So that means, so more number of atoms are involving in a reaction, so that it can boost the performance in different fields. And large surface energy, spatial confinement, reduced imperfections. So because of these reasons, because of the high surface area, participation of more number of atoms, because of the high surface energy, and reduced imperfections, which all leads to the good performance in nano scale for any material. So a wide range of applications in day-to-day life due to its unique properties. So every day, in almost everybody is using nanomaterials in their personal life. So from using sunscreen lotions to device, everything is included with nanoscience and nanotechnology. So this is the you can see the number of atoms and the surface atoms. So as the particle size is reducing, the atoms on the surface is increasing. See, if you see here, the increasing size, the surface atoms will increase. Here you can easily observe how a surface area is increasing in nanomaterial. See, if you read this, nanoparticles are the small particles with a big future. As surface to volume ratio increases, a greater amount of substance comes in contact with surrounding material. This results in better catalysts, since a greater proportion of the material is exposed for potential reaction. Example, which dissolves faster in water. See, for example, these are the sugar and these are the sugar cubes. So okay, before discussing this, if you see here, so this is a cube of each side is 1 meter, length, width, height, 1 meter, 1 meter, 1 meter. So if you calculate the area, so this is 6 meter square, 6 meter square. Now we are dividing the same cube into 8 parts, so you can see the calculation, 6 into 1 meter square. So this is for 1 cube. Here 6 into 1 by 2 meter square into, where we make this the same cube into 8. So here the surface area is 12 meter square. The same material, if you divide into 8 parts, its surface area increases from 6 meter square to 12 meter square. For example, if you divide the same cube into 27 parts, 27 equal parts, then the surface area is 18 meter square. That means from a bulk material, from a big material, the parts, the size is decreasing, so we can say simply its surface area is increasing. So as we studied in our previous slide, so the high surface area is the main reason. High surface area is the main reason for a nanomaterial, because surface area is very less for bulk material, but for the same material under nanoscale it increases high surface area. And this is the proof where we can observe the same for bulk material the surface is 6 meter square, because only atoms at surface can participate in a reaction. So here the area is only 6 meter square. That means the atoms of 6 meter square surface only participate in a reaction. But here if you see this, here 12 meter square, that means surface area increases. So you can observe more number of atoms because the surface area is increasing 12 meter square. That means though the atoms in 12 meter square area will participate in a reaction, so that its performance is increasing, any kind of performance, because the number of atoms at the surface increased. The same here in this case, the area is even increases to 18 meter square. That means more number of atoms are existed at the surface. So that means, so like this, when a material comes from bulk material to nanomaterial, that means when the size of the particle or size of the material decreasing, that means its surface area increases, which gives high surface area. Yeah, in this case sugar cubes have low surface area, but in case of this sugar we have very small particles. That's why as I told, it has more surface area, so that it can dissolve very faster, because most of the atoms are on the surface because of the high surface area, so it is easily dissolves. So this is the bulk material, and this is it's not exactly the nanomaterial, but if you observe the size difference, so this size comes to this size, so this sugar can be dissolved faster. Yeah. Coming to the history and background of this nanoscience and nanotechnology, ancient Greeks and Romans used lead sulfide nanoparticles to make the black to grey color of hair permanently in Middle Ages. At the 4th century, when Romans were using nano-sized metals to decorate glasses and cups, under normal lighting, the cup is appearing green. However, when illuminated, it becomes vibrant red in color. For example, if you see this cup, this is in green color in or general usually, but if it is illuminated by light, the same cup will be seen in red color. So that means this is the same material, but with the use of nano material coating, you can observe differently. An understanding of the science behind these materials started by Michael Faraday's research in the middle of 19th century. So this is one of the famous figures in of the basic nanoscience and technology. You can see the green in reflected light, B red in transmitted light. These are some of the milestones in the field of nanoscience and nanotechnology. The first ever concept was presented in 1959 by the famous professor of Physics, Dr. Richard Feynman, who gave a very famous visionary talk called "There is plenty of room at the bottom." This quotation is very famous in nanoscience and nanotechnology by this quotation made by Richard Feynman. There is plenty of room at the bottom. The term nanotechnology had been coined by Norio Taniguchi. I think he is a Japan scientist in 1974 by considering top-down approach. Actually, there is two processes or two methods in nanotechnology based on the preparation top-down and bottom-up. That we will discuss about these topics in our next class in our coming talks. In 1979, Drexler encountered Feynman's talk on atomic manipulation and nano factories. He has proposed ideas for molecular nanotechnology, which is the self-assembly of molecules. Invention of the scanning tunneling microscope in 1981 and the discovery of fullerene C60 in 1985 lead to the emergence of nanotechnology. And for this invention, they are awarded by the Nobel Prize in Physics in 1986. So these are some of the major things happening in the history of nanotechnology. Yeah, coming to the important topic, classification of nanomaterials. Nanomaterials can be classified primarily into two types: natural nanomaterials, artificial nanomaterials. Natural nanomaterials which are belonging to the resource of nature are defined as natural nanomaterials. Actually, without our preparation in the nature, we can observe few things which existed in nanoscale. For example, some kinds of viruses and substances in our bone matrix, proteins, the DNA which is in our body. So these are all comes under natural nanomaterials. We were not prepared them, but by its natural existence, they are under nanomaterial scale. That's why they can be called as natural nanomaterials. The second is artificial nanomaterials. These are the ones that are fabricated, prepared by different experiments. They can further subdivided into three classes: organic nanomaterials, inorganic nanomaterials, hybrid nanomaterials. So these are all the nanomaterials which we can prepare in our laboratories. So these are all artificial nanomaterials. In artificial nanomaterials, based on its properties, based on its chemical properties and optical properties, we can divide into three categories like organic nanomaterials, inorganic nanomaterials, hybrid nanomaterials, like that. See, here you can observe nanomaterials, the classification: organic nanomaterials, inorganic nanomaterials, hybrid nanomaterials. So some materials under organic materials you can observe fullerenes, that means C60, C70, or it can be also called as buckyball, and nanotubes. Based on the morphology, we can divide this one: carbon CNT. CNT means carbon nanotube, carbon nanotubes. So out of these carbon nanotubes, we have different two kinds of carbon nanotubes: single-walled carbon nanotubes and multi-wall carbon nanotubes. So these are very important class of nanomaterials, which in different kinds of materials, and particularly mechanical also. And also electrospun nanofibers. So it is one type of preparation of nanomaterials technique. So by which can be used in the fields of cellulose, biocellulose, GNF, like that materials. In also we have inorganic nanomaterials. In inorganic nanomaterials we have different kinds like these: metals, silver, aluminum, gold, copper, zinc. So these comes under inorganic nanomaterials, and also metal oxide based inorganic nanomaterials. Inorganic